Hey guys, welcome back to the laboratory. In this video, we are looking at the preparation of copper sulfate using an acid and an insoluble base. By the end of this video, you should be able to recall that the neutralization reaction between an acid and an insoluble base will form a soluble salt. Describe how copper sulfate is prepared using copper oxide and sulfuric acid, and explain the need for particular steps when preparing copper sulfate using copper oxide and sulfuric acid. So, let's go. A soluble salt can be prepared via the neutralization reaction between an insoluble base and an acid. More commonly, the insoluble base used is a metal oxide or a metal hydroxide. Copper sulfate can be prepared via the neutralization reaction between copper oxide, an insoluble metal oxide, and sulfuric acid. The word equation for this reaction would look like this, where the copper oxide and sulfuric acid are the reactants, and the copper sulfate and water are the products. It's important that you are familiar with the appearance of copper oxide and copper sulfate, as these have been examined in past papers. Copper oxide is a fine black powder, and copper sulfate is a blue chemical. The preparation of copper sulfate via the neutralization reaction between copper oxide and sulfuric acid requires for 5 simple steps. To begin with, the sulfuric acid is added to a beaker and gently heated using a water bath or a Bunsen burner. Heating the acid helps to increase the rate of the reaction, as the acid molecules gain energy and so are more likely to collide with the reacting copper oxide molecules. Next, the copper oxide is added to the beaker until it is in excess. You'll know this has occurred once the copper oxide begins to settle at the bottom of the beaker and the colour of the solution no longer changes. Adding the copper oxide until it is in excess means that all of your acid has reacted and will ensure that the salt formed is not contaminated. We now have a mixture containing copper sulfate solution and copper oxide. Step 3 removes the excess copper oxide from the copper sulfate solution using filtration. The mixture is poured through a filter funnel lined with filter paper. The copper oxide is trapped in the filter paper and the copper sulfate solution passes through into the conical flask. Next, we get rid of the water in the copper sulfate solution using evaporation. At this stage, the salt solution is added to an evaporating basin and heated using a Bunsen burner. The solution is heated until almost all of the water has evaporated. As the water has a lower boiling point than the salt, heating the solution will remove the majority of water from the solution, leaving behind a concentrated salt solution. Finally, the rest of the solution is left to stand. This will allow the remainder of the water to evaporate from the solution, allowing crystallization of the salt to occur. Here's an example of a past paper question that you can attempt to test your understanding of the concepts covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Part 1 of this question asks for you to draw a diagram of the apparatus used to filter the excess calcium carbonate from the mixture. The apparatus would of course be that used for filtration and will therefore consist of a filter funnel lined with filter paper and a conical flask. The second part of this question asks for you to explain why the calcium carbonate is added until some of the solid remains at the bottom of the beaker. This is of course to react all of the acid in the solution, ensuring that the calcium nitrate solution is pure. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!